Hello everyone. Today we will discuss some special form of integration. The first one is given I equals to integration of under root tan x divided by sin x cos x into dx. The whole thing is divided by cos square x individually, both the numerator and the denominator. The numerator becomes under root tan x into sec square x into dx, and the denominator becomes tan x. Now simplifying root tan x at the numerator and the denominator as tan x, the whole thing becomes as integration of sec square x dx whole divided by under root tan x. Now assuming p square is equal to tan x, taking differentiations 2p into dp is equal to sec square x into dx. So instead of this expression, we are using all of these. Instead of sec square x dx, we are using 2p dp and under root tan x. This is substituted by p, and p counterbalanced. 2 into the whole thing becomes as 2 into integration of dp, hence it will be 2 into p plus c. Further, p is substituted by under root tan x, 2 into under root tan x plus c. The second one is I equals to integration of tan x dx whole divided by sec x plus cos x, multiplying both the numerator and the denominator by cos x. Integration of sin x dx divided by 1 plus cos square x. Now taking cos x equals to p, taking differentiation dp is equal to minus sin x into dx. Hence the original expression becomes integration of minus of dp whole divided by 1 plus p square, and it will become cot inverse p plus c. Now p is substituted by cos x, the whole thing becomes as cot inverse cos x plus c. The third one, I equals to integration of sin cube x dx. We know sin 3 theta is equal to 3 sin theta minus 4 sin 3 sin theta minus 4 sin cube theta. The sin cube x, hence it is replaced by 3 sin x minus sin 3x. 3 sin x minus sin 3x whole divided by 4 into dx. The whole thing is integrated with respect to x. The whole thing becomes as 1 by 4 into cos of 3x by 3 for this one, and for this one minus 3 cos x plus c. Then the next one, I equals to cos square 3x dx. It will become, as we know, cos 2 theta is equal to 1 plus 2 cos square theta. Hence the cos square 3x is substituted by 1 plus cos 6x by 2 plus 1 plus cos 6x by 2 into dx. Therefore, it will become half into 1 plus cos 6x into dx, and integrate with reference to x, with respect to x, it will be x plus sin 6x by 6 sin 6x by 6 plus c. The next one, I equals to integration of cos x into cos 2x into cos 3x into dx. Taking these two, cos x and cos 3x as a group, half into integration of 2 cos x into cos 3x into cos 2x, the middle one separated from here, into dx. Half into, this will be expressed as cos 4x plus cos 2x into cos 2x. Again, half into 2 is counterbalanced. 1 by 4 into 2 or 2 into cos 4x into cos 2x, cos 4x into cos 2x plus 2 cos square 2x dx. 2 cos 4x into cos 2x is simplified as cos 6x plus cos 2x, and 2 cos square 2x is simplified as 1 plus cos 4x into dx. The whole thing can be proceed by yourself. Try to do, and if you facing any complex, then ask me via YouTube. The next one, integration of sec 4x into tan x dx. Let us assuming p equals to tan x, therefore dp is equal to sec square x into dx, sec square into dx. The sec 4x is subdivided by sec square x into 1 plus tan square x, as 1 plus tan square x equals to another sec square x into tan x as it was before into dx. Now substituting the tan x as p, so 1 plus p square for this one, and sec square x dx equals to dp, and tan x individually as p. and proceed yourself. Then the next one, I equals to integration of sine 4x by sine x into dx. Sine 4x can be written as 2 sine 2x into cos 2x dx divided by sine x. Sine 2x further can be written as 2 into 2 sine x cos x into cos 2x dx whole divided by sine x. So sine x at the numerator and the denominator both are counterbalanced, and 2 is taken out as common. 2 into integration of 2 cos x cos 3x dx further can be written as equals to 2 into cos 4x plus cos 2x into dx. Proceed yourself. The next one, I equals to cos to the power 5x dx. We can write it as 1 minus sine squared x whole square 1 minus sine squared x whole square into cos x dx. Taking p equals to sine x, so dp equals to cos x dx. The whole thing is substituted by 1 minus p square whole square into dp. Then proceed yourself. The next one, I equals to sine square x into cos cube x dx. This thing can be written as integration of sine square x into 1 minus sine square x 1 minus sine square x into cos x dx. Taking p is equal to sine x, thereafter dp is equal to cos x dx. Sine x is substituted by p, substituted by p square into 1 minus p square into dp. P square for sine square and 1 minus p square for 1 minus sine square x, and cos x dx is substituted by dp. Then proceed yourself. Okay, thank you everyone, and try to do the rest of the sums and ask me if you have any complex.